fast.
Yeah, it's very good. So it's a form of log, right?
Huh?
It's a form of log, right?
Log, yeah, it's just JSON.
Okay. Okay, then it would be pretty straightforward.
Yeah.
Okay, I have to just find the right part, and it seems I have a feeling it might be doable.
Yeah, it's doable for sure. It's just,
Yeah, but how much?
it just
how much
take
time?
some time.
You prioritize.
Yeah. Okay, I
Very
think we
good.
have to start the next session.
Yeah, of course.
Okay, yeah, it's good to meet you. Your name is?
My name is Bezad
Bizard.
Bordpar.
Okay. All right, from
Yeah,
Birmingham.
people call me Bez.
Bez. All right, I'll
For
try to
sure.
remember that. Yeah, thank you. Hey, you must be Tug.
Yeah, I'm Tug.
Hi, I'm Andrew. I'll be introducing you. Is there anything you want me to say?
No, no, no.
Okay, all right. The first thing we do is like you get off the stage and then I'll introduce you and then
I believe that there are probably better ways to solve that.
Hi, everyone. For our last speaker, we have the Chief Technical Evangelist from MapR. Today, he will talk about complex data with Spark. So please help me welcome Tug Rawl.
So, good afternoon. So, as said, I will talk now about how you have to deal with more and more complex data, on how you can easily integrate the complex data structure into your Spark applications. So, one of the key challenges we see is the number of data that we have to deal with is doubling. It's going fast into our systems. And the structured data we have to deal with, it's not growing that fast compared with the unstructured data we have to deal with. Think about all the logs you have to deal, you capture, talk about all the, if you are working on an IoT project, the number of sensors sending data into the applications, into your storage. And one of the challenges is how do you deal with that when you build your applications? How do you access this information? And one of the goals that we have when we want to build the application, we want to make it very simple to do that. And more data, at least in terms of volume, are not stored anymore into your relational schema-first database, but more in a non-relational data store, like any NoSQL engine, in your HBase, in your Hadoop file system, where you will store all this information. And you want to be able to add data immediately in this store and be able to use them in these applications. And many challenges are coming when you are doing that. How do you access this information easily? How do you build application? How you do query? How you do analytics? And some options are coming with, obviously, all the Spark ecosystem, all the Spark stacks, but also what you have, for example, in a project I have been involved with, that is Apache Drill. So the goal tonight is to talk about Apache Drill itself as a project, what it is, and how we could help you to to be faster, to be more efficient when you build applications with complex data, but also the link, obviously, between Apache Drill and Apache Spark to manage this very set of complex data. And I will finish with the status of the project on what will be the next step in the project. So one important part 3 years ago when Drill was started, one of the first ideas was you want to be able to query your data without having to understand the schema or build the schema. You start to discover the structure based on the file you have inside your file system, based on the database you want to connect to NoSQL or SQL database. And this is what we call point-on-query versus defining the schema. And you want to access any data, and we will see some example later. And because you want to integrate that with many, many other tools, you want to have an ANSI SQL engine where you can use any of the select aggregation frameworks, the join, or the windowing function into a standard query language based on SQL. And provide connectors using JDBC and DDBC to integrate that with your application. All the BI tool, as you can guess, but for example, also as a data source of the Spark engine. And like any time we talk about applications, data, large applications, large volume, you want to be fast, easy to use, and continue to perform very well when you scale, adding many, many, many nodes to your cluster, the same way you do with Spark today. And you want to be able to start first, so extremely easy to use. You want to install and start. All the engine of Drill has been built on the Dremel paper that you can read from, that had been published by Google a few years back. And the contributions on the Drill project come from many companies to make it very efficient when you want to work with various sources of data in the context of a SQL engine. When you build your queries, because you can access many data sources, the select statement will be a little bit different from what you know. First, you will have the storage. Which data source do you want to use? Do you want to use a file system? Do you want to use a database like a NoSQL database, like HBase, MapRDB, for example, MongoDB, or Cassandra? Or reuse some of the database or system you have defined, like the Hive metadata, like a relational database that you can connect to. Then, depending on the plugin storage you are using, the workspace. So is it a subdirectory on a file system? You want to analyze all the log file in one select statement with the subdirectories organized by months or organized by years. And same, if you have a database, it will be the name of the database. It will be the name of the collections, for example, when you want to move to a MongoDB instance. And you continue to do the query like that. So special way of addressing what we will call a table in a normal SQL statement. And the where clause will be, as you can expect, using all the ANSI SQL where, group by, having, and sort, and so on. One of the challenges when you work with a SQL engine will be how do you deploy that? And you want to be able to deploy that on any data with a close to the data, to work on the data locality. Depending on the type of cluster of data source you have, you may have very complex deployment using Hadoop, HBase, very large deployment, using HDFS, using HBase, using our other MongoDB or other NoSQL engine, or simply a cloud service where you have many files. Or you want even to start on your single laptop, on your single Windows or Mac or Linux machine. The goal of, in this case, of working with Drill is just you put your Drill engine, what we call a Drill bit, close to your data. The same way, when you work with Spark, you are putting your different Spark engine close to your data, close to the data you have to process. So the goal now is just to see how the engine is working and what's the link between Drill as a SQL engine and Spark. So each Drill bit is a complete self-contained process that has many components. It will receive the SQL. So the first thing it will execute, it will parse the SQL and create a logical plan. And depending on the storage you will be using, it will create will go through the optimizer to do a physical plan and then execute that on all the nodes where your data are. And you have a list of the different data sources you can use, for example. Everything that is in blue could be extended. And this is one very important part about Drill. It has been built to quickly give you access to anybody that can write SQL, to many data sources. And if you want to extend your system to parse, to execute query on any type of data sources, you just have to create the storage plugin first to connect and to say how you access the data, and then define how the optimizer will do the query and push down as much as possible the query information into the storage. Obviously, when it's a file system, it's just about distributing the query between the different nodes. When it's accessing a NoSQL engine, it's pushing the where clause, the filter to the engine, the sort and the limits to the engine. In which case, for which type of deployment you will integrate Apache Drill and Spark together, you have a specific storage, you want to be able to read that. You have different ways of looking at that. Either Drill could be the data source for your Spark job, or you want to be able to start to work on Spark, create RDDs, manipulate data frame, and expose that using Apache Drill. It will depend on the type of manipulation you want to do. It will depend on the type of join you want to do between your data sources. You may want, in specific intermediate state of your job, be able to query directly the data you have in Spark in memory and join that with another data source without having complex things to do. At the end, you can choose to continue to work, obviously, with Drill and save back, using your Spark job, some data that has been transformed, enriched, using any of the library you have inside Spark into files, into database, depending on your application requirements. And a big, big use case for Drill is really all about business intelligence and analytics. The support of SQL, the support of JDBC and ADBC give access to all the existing tools you have in your company to create dashboard, to analyze with different tools like Tableau and QlikView directly using a query that in this case will be a mix of accessing directly the data sources, accessing some information about a Spark RDD and memory. One of the challenges I initially stated during the fact that we have to deal with more and more data is the fact that you have to deal with very complex data sometimes. If the world was only made of rows and columns, we could still work with relational database easily. But in fact, in many cases, and in this case I am using a data set that is available publicly, an open data set coming from Yelp, that contains all the businesses, the users, the rating, and the tip and checking of different users into businesses, and everything is based on multiple JSON files. And if you look at this specific structure, this is an example of one single business. You see that you have an ID, a description, but you have very complex structure, like, for example, the open hours. You have an attribute for a list of attributes, a complex sub-document that contain each day, or for each day as a sub-document with open and close hour. Same, a business may be part of multiple categories. It's a restaurant in this case that accepts breakfast, and is a steakhouse. I don't want to mix both of them. And a French restaurant, for example. So one of the challenges when you have to deal with that is how do you access, how do you do some aggregations, how do you parse this information and query this information with a SQL language that has been built to do rows and columns without having to code anything. The goal of Drill is you have the data, you start to write SQL immediately. You don't need to write any code, you just execute your SQL statement. Another example of a document that is part of Yelp will be the reviews. The review will contain simple attributes with a user ID and a review ID. The user ID will be used to join back to the user or back to the business using the business ID. So you have to do join between different files in this case. The same way you will do a join using a foreign key in a relational database. And also you have some interesting data structure in this case that the votes contain different attributes. We like a type, like is it funny with a rating, useful with a rate, and so on. So you see that in this case, we have complex document. So how do you start or give this to the user that wants to work with SQL to be able to consume that in the context of a Spark application? Drill is a single process you have to run. I talk about a drill bit. So you will download it, unzip, and start. And obviously, in this case, as you see, it's drill embedded. It's a single node running on a single process. If you work in the context of a large cluster, you will have a different configurations, for example, using Zookeeper to distribute and manage all the nodes of your cluster. If you look at the statement itself, very, very simple. The only thing that is different from what you know from SQL will be the from part, where you have the DFS to say, I go to the file system. Yelp will be a shortcut or a name of a directory, and then you have a file. In this case, a JSON compressed file. That will be automatically parsed, executed, loaded in memory. If it could be distributed, it will distribute that on many processes and do the group by, do the order by on the limit directly on the node. In this case, it will use brute force to read the file, do the aggregation in memory, and so on. Since you may have to deal with very, very large data set, everything, all the data manipulations, the aggregations, the calculations, is based on a columnar representation in memory, not inside the heap of the JVM, but off heap to be efficient. So you don't have to deal with the configurations of your VM and the configuration of the garbage collector, since all the objects will be manipulated off heap. Since we are working with advanced document or advanced and complex data structure, Drill has extended the SQL to have specific functions. For example, when you look at a specific column that is made of a document on a subdocument on an attribute, you will use a dot notation. In this case, I'm looking for some specific restaurants that are open at 10 p.m. and are Mediterranean restaurants. I will have two specific things here. You see B being the table, business table, hours.friday.open, and greater than and lower than. Just the specific notation that is an extension of what you can do with a standard SQL, you will say. And use repeated contains to manipulate list. So what is important for you from a developer point of view, you don't have anything to do with the schema. You discover and use the schema as it goes out of your storage. This data can be consumed by any of your applications, including Spark application. All the join subqueries can be executed. In this case, I am looking into the review to find the coolest places in my Yelp database, that is a set of JSON files. And I'm just looking at grouping stuff, doing a sum, and finding all the specific businesses that have more than 2,000 votes. And then, by the sum of the votes, it's bigger than 2,000. And then I use that as a query to feed all the cool JSON, all the cool business that I want to use. So you see two queries. And you have everything in Drill to do the explain plan optimization of the queries. One important here is to make it easy for your development to integrate these queries into your application. Not necessarily to provide Spark SQL to do the same thing. Is you have existing team working with Drill on your business intelligence data warehouse. You want to consume that easily inside your application to process the data. In this case, it could be interesting to create a view just to hide the complexity of the query. In this case, the view, like in a standard SQL engine, will just be a shortcut to a specific queries, like you see on the second line, select count from my view. In this case, we save the query into the file system, on the distributed file system, and it will be executed directly. Another part that is very interesting, I don't know how you work with data, but sometimes when I have a very large volume of data coming from CSV or JSON, the first thing I do to make it more efficient when I work is to convert it to a specific format, Avro or Parquet or Apache Parquet or whatever. one way of doing that is just to create a table inside drill. In this case, it will execute the query, because in this specific session, the format to store the data is Parquet. It will create multiple Parquet partitions into the file system, allowing then either drill to use the Parquet file or your Spark applications to consume and use these Parquet files. So once again, everything will be about optimization, speed, and managing complex data. Parquet will support the nested elements, the list, the subdocuments, and so on. If you have very complex, and this is a difference with some of other SQL engines, including Spark, is the way you have to manage complex data. So if you have a list of value, if you have a list of subdocuments, it's very hard to do query on that. In the relational world, you will have two tables. And if you want to give me the most used category in a specific, in my business, you will just have to do a join between the category table, the business, do a count, and so on. In this case, everything is in one single attribute as a list. So what you have to do, it's you already have the join between these two tables in one single document. So you have to do the opposite. You have to transform using the flatten function, take all the attributes as a single value, and move them as a single value as a row. If you look at, for example, the first business, Eric Goldberg as a doctor, is a doctor on health and medical categories. When you do the flatten, you have now two lines for this specific business. Eric Goldberg as a doctor, Eric Goldberg as a health and medical business. When you have that, you can now deal with more complex queries to do, for example, give me all the categories for all the business, do a count for the most used categories, the most famous categories. As you can guess, in Yelp, restaurants are the most used categories. So you will be able to deal with very, very complex data, to expose this data as a single table on rows or subdocuments for any of your application. So you can then build data frame easily or drill RDD easily. Same if you use HBase or another complex, another database that does not support natively documents, you can store JSON file into a specific column and use a convert from function of drill that will say that if this field is a document, convert it to JSON and then do any query you want. In this case, you will execute the query inside the database, convert the field into a JSON document, and you use the result of the document as a data source for the other query. So for example, when I use HBase to store JSON document to do some aggregations, calculations, because I need a rich representation of the data, this is how I integrate queries into my application easily. An important part that will make also very easy the integration to your Spark applications is when you have many data sources, you want to do join, you want to do aggregation between different data sources. Sure, you can use the SQL, the data frame integrations, and build your own join and all this stuff. Or you use this simple query. In this case, I have a join between a Parquet file, a Mongo collection, and a JSON file to find, in this case, the most active user in my database by category. So you do a join between the collection that contains, if I remember, the user, and the category, the reviewer are in a Parquet file, the user are in a Mongo table and Mongo collection, and the business in a JSON file. So imagine all the data sources you can mix together. Keep in mind, we will use the brute force of the cluster if we cannot push down the filter and so on. Obviously, the join will be done in memory in the drill cluster. So the goal of that is when you know how to build queries, you start to use the queries in different BI tool or in some part of your application, it's to integrate that into your Spark application. So the first thing we have been working on is to directly allow you to quickly use a select statement that point to a drill engine. without using JDBC on direct connection, like if you were using a relational database, but just write your SQL statement in your Spark application. In the context of your Spark job, just send that, and you will, using the drill RDD method, and it will return you an RDD on which one you can work like any other data set you want into Spark. And what is special here, depending on the complexity, so this is one of the reasons we could also build the same way a data frame, but what is important here is a document or the list of documents you have in an RDD are complex structure. They are JSON documents with sub-element, arrays, and so on. For example, in this case, I will give me all the restaurants, getting some field from that, and some of the information, like the open hours and close hours, are sub-documents on specific attributes that cannot necessarily be easily represented in a simple data frame. The other part that is also interesting in the integration is to be able to work directly on the RDD from drill if you want to do some join, some work. In this case, obviously, it doesn't have to be in exactly the same place. But here, you build a specific set of objects as an RDD. So the square object will be a map of object. You register that as a table, and then you can, if you want, using the drill engine, execute the request on it, a query on it, sorry. And in this case, you will be able to do some aggregations, complex manipulation of the data, convert that into different format if you want, using a select statement, not using specific code. It will really depend on your background as a developer. What do you like to do? How do you want to work? So the benefits of working with the two technology is Apache Drill is focusing only on SQL. It's to make life easier to, as a starting point, you write SQL queries. And in addition to that, you can build many data sources, integrate data sources, build custom functions to transform the objects you are manipulating, and have many existing storage that could be joined together automatically using queries. The way we work in memory is also different. It's very efficient working off-heap with a columnar and vectors in memory to make it very, very fast to do the join and all this stuff off the heap of the JVM. But we want, as a developer, to let you obviously leverage the power of Spark. You are more efficient as a developer. You go a lot faster when you want to develop a specific application on job compared with other systems. Remember MapReduce, for example. You want to integrate that to your process of manipulating the data. And obviously, you want to be able to leverage the distributed processing in the context of running your queries, integrating with your queries in the Spark engine. So what's the status of the project? We are finishing the development of this integration between Drill and Spark to be able to integrate RDDs directly coming from or to Drill. And this is, for now, at least for this first version, the way you deal with memory is one side will be part of the Spark cluster and the Drill cluster, and we have to serialize the object between something that is columnar in Drill against something that is row-oriented in the heap inside Spark. I've not tested with Tachyon, so I don't know how it works when you are off the heap. And continue to work on be able to work better when you have the processes, the Spark processes on the Spark Drill on the same servers to make it more efficient. So if you are interested to look at how to work with the two technology, especially if a part of your team is always starting with SQL is your first development language to process, integrate the data, and you want to reuse complex queries they have built, look at this Drill on Spark integration. It's an Apache project, so join the mailing list, the user on the dev mailing list. And as a developer, as a user, I invite you to just look at the Apache website on online training. You will be able to see how easily you can start with that and see how you can also start to integrate drill into your Spark applications. So we have a few minutes for questions. Do you have any questions? Yeah.
Thank you for your presentation. Do you plan to integrate data frames?
So we started with RDD first because when we started, data frame were not here. So it was one very good reason. And also, we have to see how we deal with very complex data structure. So for simple structure will be easy. And we can, especially on JSON, start to guess what will be the schema. But the plan is yes. But we want first to have this specific RDD-oriented first.
Okay, so it seems that you don't support Cassandra as data source.
It's not yet. It's an open source project, so we have contribution from different people. You had one contribution that is not yet in master. So I don't remember on which repo it is. It's working, but it has not been testing entirely. So this is why it's not inside the master branch. It's currently as a pull request inside the drill repository.
So what also interests me, so basically a drill is a distributed SQL engine, yeah?
Yes.
So do you have any benchmarks comparing to Spark SQL, for example, for complex and simple queries, how it compares?
So if you ask me, what do you think the benchmark will be? So the big answer about benchmark, it depends who are using them. I know that during a Hadoop user group in Japan, people have done some benchmarks. So they had a few hours of sessions on SQL, on Hadoop as a big bucket, and they tested Spark SQL drill on other, like Hive and on other SQL engine. Depending on the query, the drill is faster or not. It really depends on the case by case and also on the data sources. So we don't have official benchmark on that. But it's a case by case, honestly.
Okay, thank you.
So
we'll take one more question.
So thank you very much.
Thank you. So that marks the end of Spark Summit. Thank you all for coming.